Well, we've had straight lines crossing straight lines. We've had straight lines crossing parabolae. Why not two parabolae crossing each other? Here we have two, and very superficially their shapes are 6x squared is a tall, skinny parabola, 2x squared is more of a short, fat parabola, and so, in theory, these two things could cross twice. They don't have to cross twice, though. They could also cross once, if you pick that location very precisely, or they could cross not at all if the second one passes under the first. Algebra can tell us which. We'll just say that the first curve, 6x squared plus 7x minus 4, is exactly equal to the bottom curve. That's basically saying that these two curves are touching, and then we'll find out when that happens. I'm going to take everything over to the left-hand side. We'll get an expression which I hope we will factor, and that'll tell us where the intersections are. So 6x squared minus 2x squared leaves 4x squared. 7x plus one more x gives 8x. And minus 4 minus another 1 leaves minus 5, and it equals 0. So, we haven't had to do decomposition in a little while, but I think we need it now. We need two numbers which add up to 8, and which multiply to 4 times negative 5 is negative 20. Ideas? Here's all the ways you can make 20. Short list, which is nice. 2 and 10 look good, don't they? If we had a minus 2 and a plus 10, those would add up to 8, and multiplying them would give negative 20. So 4x squared minus 2x plus 10x minus 5 equals 0. Factor the first pair, you can take out a 2x, which leaves us with 2x minus 1. Take a 5 out of the second pair, and you get 2x minus 1, and it all equals 0. And take out 2x minus 1, leaves us with, the common factor is 2x minus 1, I mean, and with that gone, you're left with the 2x and the plus 5. So, we get two solutions. I'll do this over here. Either 2x minus 1 equals 0, which means x is 1/2, or option 2, 2x plus 5 equals 0, which means x is minus 5 over 2, or minus 2.5. Those would be the solutions to the system of equations. The fact that there are two of them tells us the curve looks more like this, where the first parabola goes in through the first parabola and then out the other side. Now, next they say, sketch the equations on the grid and use a graphing technique to determine the solution to the system. State an appropriate window. In other words, do it again with the calculator. And I'm sure they're interested to see if we get the same answer that way. So, here comes the calculator. Bring this up so we have a little bit more space. There we are. So, we are graphing 6x squared plus 7x minus 4 is our first graph. 6x squared plus 7x minus 4. There we go. And our second equation is 2x squared minus x plus 1. Okay. So there are the two graphs. One of the intersection points looks like it's a little ways up. I'm going to push the window upwards a little so we can see that more clearly. Still not wonderful, but I'll give it a little more room. Get down there, you. Okay, I can live with that. So we have one crossing point there, another one there, and calc intersect will tell us where they are. So second trace intersect. First curve, yes, that is the first curve. Yes, that is the second curve. And for the guess, I'm going to put the bug right over here. And it reports minus 2.5. Great, that's our minus 5 over 2, so we were right about that one. For the other intersection, second trace, intersect. Yes, that's the first curve. Yes, that's the second curve. And now I move the guess over to here, and it finds 0.5, which is our solution of 1/2. So yes, algebra produced the same results that the calculator did. And state an appropriate window, sorry. The window I ended up with was this one. I left the x's at the default values that the calculator starts with. The y minimum I left at minus 10. The y maximum I pushed up to 25 because 10 wasn't quite enough. And I almost never change the scales or the resolution unless I'm trying to make an extraordinarily pretty graph. And verify that the solution obtained satisfies both equations. Well, if you substitute, I don't believe I have space to do it here, but if you substitute 1/2 into the first equation and the second equation, you should get the same result. I'll see if I can squeeze one of them in. You would have to do 6x squared plus 7x minus 4, and that equals, we hope, 2x squared minus x plus 1. How does that come out? 1/2 squared is 1/4. 6 times 1/4 is 6 over 4, which is 3 over 2. Plus 7 times 1/2 is 7 over 2. Minus 4 equals 1/2 squared is 1/4. 2 times 1/4 is 1/2. Minus 1/2 plus 1. So here, 3 halves plus 7 halves is 10 over 2, which is 5. 5 minus 4 is 1. And on the right side, 1/2 minus 1/2 cancels. We get 1 again. So I did the fractions a little fast there to try to save space, but you can plug 1/2 into both of these equations and they come out to the same value. You could do that again with our other solution, minus 5 over 2, and again you should get the same number on both sides. It may not necessarily be 1, but it should be the same number. As long as that's true, then your solution satisfied the equations. If you get something like 5 equals 8 at the end, that means no good, the solution is not valid. So give that a try if you like. Make sure you can confidently plug these values in and confirm that they work.